Calculations with wavelength, speed, energy, and frequency of light can connect to atomic structure, can connect to bond energy with radiation caused to vibrate or to rotate a bond, or could be related to solutions, their colors, and lots of other things. So it's an important piece where we are very comfortable not only with the equations, but with the different units, and then comparing those from one to another. So here we are asked about the energy of light. Often visible light has a unit of nanometers. Nanometers is not a prefix that we would be given and need or any information about how to convert. So we need to remember that nano in this case is like 9. So nano to the -9 there. So we plug these numbers in. That would be the same as 585 to the -9 or 5.85 to the -7. And then we get a frequency of 5 to the +14. Once I plug that into the other equation, I get that many joules. And that's how many joules I would have per photon. You'll see in some questions about ionization energy or atomic structure, or even here where it may ask per mole. That is joules per photon or per particle. We would then need to use Avogadro's number if we're doing this per mole. That's often where we would take a number that's a small number of joules and be able to convert it to kilojoules. If we're looking at bond energies, for example, the bond energy might be a certain number of kilojoules per mole. And we would want to think, is this enough energy to break that bond or to stretch that bond or rotate that bond? And in any of those cases, we would want to convert that to how much would there be for a full mole. Here we are given an energy, it's absorbed by a molecule, making that connection as to the different types of photons. And we don't need to memorize their exact energy, wavelength, or frequency. But we do need to be able to, if given a range, compare them. And in this case, we plug that in and we would see that that frequency is in the infrared range. Infrared is a little bit less than visible light. Visible light is moving electrons up and down. Infrared is vibrating our molecules. And a little bit lower than that, microwave is rotating the molecules. We should also think about if we had significantly more energy, once again, breaking bonds, or if we were talking about a single atom, removing an electron, an ionization energy. So there's connections across all of these things. It all comes back to the force of attraction from Coulomb's law. So any energy associated with a photon of light or a specific color of light can be compared to the energy from a bond, from an IMF, or from any type of attraction.